Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today we are going to learn different tunneling diode applications, tunnel diode applications. So let us see the overview of today's presentation. So we will start with the introduction to the tunnel diode and tunneling effect, types of tunnel diodes we'll discuss, and advantages of tunnel diode and applications of tunnel diode, and then conclude with the summary part. Tunnel diode. So tunnel diode exploit a strange quantum phenomena called resonant tunneling to provide negative resistance forward bias characteristics. So this is the basic nature of peculiar property of tunneling diode. So it is specially designed to have a negative resistance characteristics, and it exploits a strange quantum phenomena called resonant tunneling to provide a negative resistance forward bias characteristics. The tunneling diode is also known as Esaki diode because it is invented by Leo Esaki in 1957, and for this invention he received Nobel Prize in 1973. So they were longer lived than traveling wave tube amplifiers, so an important consideration in satellite transmitters. So tunnel diodes are very useful because they are used in satellite transmitters for amplification of the signals. So usually in olden days, so we'll use traveling wave tube amplifiers, so which are works at micro frequencies. So the traveling wave amplifiers occupies more space, and then of course the noise also more in case of traveling wave amplifiers. So these are the drawbacks. So these type of micro traveling wave tube amplifiers cannot be used in satellite transmitters. So it will become bulky and noisy. Gain, of course, gain is more, but less high noisy. So that is the drawback with the traveling wave tube amplifiers. So these tunnel diodes replace these traveling wave tubes because they occupy less space, and then their switching speed is more, and they can amplify the signals proper amplifier because less noisy. Hence, they can be they are best candidate for the amplification purpose in the satellite transmitters. So tunnel diodes are also resistant to radiation because of their heavily doping. So as we have already discussed, tunnel diodes are heavily doped. Due to this reason, they can be sustained for high radiations also. Usually radiation increases, temperature also increases. So due to that, some components may get damaged. So there is even small signal tunnel diodes are expensive and difficult to find today because this is one of the drawbacks of tunnel diode. They are very costly. So even small signal tunnel diodes are also expensive and difficult to find today. So however, the research is going on to manufacture different kinds of tunnel diodes based on germanium, based on silicon. So and combination of tunnel diodes with which must be integrated into some CMOS integrated circuits. So you can say they are sometimes used in military equipment because they are insensitive to radiation and large temperature changes. So usually any electronic components may change their properties with the environmental changes. For example, when with the temperature increases, the components may change their properties. So this is not desirable. So there must be some robust components. So tunnel diodes are very robust. So because of their heavily doping concentration, so they can able to sustain all the environmental condition, and the radiation also don't the tunnel diodes can also be sustained for the high radiations also. And there has been some research involving the possible integration of silicon tunnel diodes into CMOS integrated circuits. So this make the tunnel diodes more effective utilization. And because CMOS means here complementary metal oxide semiconductor. So these are the very advanced manufacturing processes, which gives, so many number of components can be integrated together into a small chip. So that is the advantage of these CMOS integrated circuits. So tunnel diodes can also be integrated with this CMOS technology, and also they are thought to be capable of switching at 100 gigahertz in digital circuits. So this is more very advantageous in case of digital circuits, because the digital circuits required switching speeds. Of course, sometimes they require some delay time also. So 100 gigahertz means so it is high frequency. So high frequency is usually the size of the equipment or component will be reduced. Compacts size will be present due to the high frequencies. So types of tunnel diodes or single well tunnel diode. So this type of diode exhibits negative differential resistance and is used in amplifiers and oscillator circuits. So there are 5 types of course there are many types of tunnel diodes. So particularly we discussed only 5 types of tunnel diodes. So particularly single well tunnel diode are used in amplifiers because this type of diode exhibits negative differential resistance. Negative differential resistance means as voltage increases, so different kinds of voltages. So multiple voltage input voltages coming for a particular tunnel diode. So differential resistance characteristics means because for different voltages, so they have to it has to be receive different kinds of voltages, and correspondingly it has to manage, and then it exhibits negative differential resistance means for depending upon the difference of the voltages, the current changes accordingly. Next one is a double barrier tunnel diode. So this diode is used in applications such as millimeter wave oscillation because it operates at high frequencies. So these are very important application or type of tunnel diode, particularly millimeter wave. Millimeter wave means so the frequency is very high, approximately up to 300 gigahertz. So from let us say 10 gigahertz to 300 gigahertz millimeter wave. So when high frequency, is there means the wavelength is very high. So because V is equal to F lambda, right? So F is equal to V by lambda. So V is velocity of electromagnetic wave, and F is the frequency, and lambda is the wavelength. So frequency and wavelength are inversely related, right? So when frequency increases up to 300 gigahertz, so the wavelength is very high. So very high means what? So the wavelength increases. They cannot travel far distances. So particularly, so in such case, this kind of double barrier tunnel diodes is used in such millimeter wave oscillators. So they have to oscillate, right? So according to the particular oscillations, so the data can be, the signals can be, signaling function can be, the signals can be retrieved from the receiver side, and they can be transmitted from the transmitter, and because it operates at high frequencies. So high frequencies, these double barrier tunnel diodes are very useful. Similarly, superlattice tunnel diode. So this is used for more precise control over the tunneling process and can lead to improved performance characteristics. So superlattice tunnel diode is another type, so which is used for more precise control over the tunneling process. So they have these superlattice tunnel diodes have some control on the tunneling process. So they can maintain balance between the tunneling process and can lead to improved performance characteristics. So these are very useful in different applications. Resonant tunneling diode. So So today we will see what is resonant tunneling diode. So the basic nature of tunnel diode is resonant tunneling diode, and they are used in many applications like amplifiers and switches. Next, SRK interband tunnel diode. So they are is an extension of traditional tunnel diode used for high frequency applications. Again, so we can modify the normal resonant tunnel diode to make SRK interband tunnel diode for high frequency applications. So coming to the advantages of tunnel diode. So what are the so if you observe, this is the practical view of your tunnel diode. So this is your practical view of the tunnel diode. So anode and cathode, and so besides you can observe the tunnel diode used in a particular application, particular circuit. So what are the advantages of these tunnel diodes? So they are very small in size. Of course, they are heavily doped and easy to fabricate, and they are very low cost, and then the low power consumption is less because they are very even though it is very heavily doped, but they are compact because obviously they require less power to excite, and then it has long life because compact. So when the things are compact, so they are very robust in nature, and then they can have long life, and then less noise. So of course, because they are tunnel diodes are compact and they generate very less noise, they balance the environmental conditions, and the switching speed is very high. So that is the most advantage of tunnel diode. Hence these kind of tunnel diodes are used in digital circuits. And what are the disadvantages of tunnel diode? So no proper DC isolation. So this is very critical condition. So when there is no DC isolation, so obviously gain changes, gain also decreases. So no proper DC isolation is there means, so DC, so for example, if you consider amplifier, so amplifier we are using some biasing circuits, DC biasing circuits. Okay, so in DC biasing circuits, some DC voltage is also flowing through the DC parameters also flowing through the circuit, amplifier circuit. So in such case, if you are not using proper operating point, or then obviously there is an increase in the even small amount of noise is enter into the our input signal to be amplified. Obviously the noise also amplified correspondingly. So therefore that is the drawback with the amplifier circuits. If you are not providing this DC isolation, so that is from input side to some DC components, then you will get the reduction in the gain. So that changes the properties or performance, that affect the performance of the circuit. And consider smaller voltage swing. So there is a smaller voltage swing, so the variation in the swing voltages, so that is also another drawback. So there must be some delay between some voltages, between some signals, two signals. So cannot be fabricated in large amount. So that is another drawback. So we cannot be fabricated in large amount, so as it is very costly. Of course, because there is a DC, it cannot provide DC isolation. So we cannot use such kind of. So we cannot design or manufacture bulky. So coming to the applications of tunnel diode, so they are high frequency oscillators. The native resistance property enables them to generate stable and precise oscillations. Okay, and the negative resistance properties plays a major role in many different applications. So they are used in variety of applications such as radio communication, radar, and satellite communication. And logic circuits. So the main application of tunnel diodes are logic circuits. where their negative resistance property allows them to switch between states quickly and with low power consumption. So in digital circuits we require very less amount of power. So in this case, so tunnel diodes are very utilized effectively because they consume less power. Tunnel diodes consume less power, and then its speed is very high. Switching speed is very high. So therefore, such kind of characteristics or features are utilized in case of digital circuits, logic circuits. So they are used in digital signal processing, data transmission, and computing. Mostly used in is the so for these kind of applications, particularly what type of tunnel diode we can choose is resonant tunneling diode type we can utilize. The third one is single photon detection. So where their high sensitivity of light enables them to detect individual photons. So tunnel diodes have a peculiar property that they can able to recognize, react for even individual photons of the light energy. These detectors are used in quantum cryptography, quantum communication, and low light imaging. So the most common type of tunnel diode used for these kind of applications are superconducting tunnel junction, and then voltage controlled oscillators. So where the negative resistance property allows them to generate oscillators that can be controlled by an external voltage. So here voltage controlled oscillator VCOs. So where the tunnel diodes negative resistance property allows them to generate oscillations that can be controlled by an external voltage. So these oscillations can be controlled by the external voltage used in the frequency modulation, phase lock loops, signal synthesis. The most common type of tunnel diode used for this kind of applications is the varactor diode, Okay, so therefore these are the different applications of tunnel diode. So let us come to the conclusion. So we have learned today. We have learned the basics of tunnel diode, introduction to the tunnel diode, and then we have discussed types of tunnel diode. So we have 5 types of tunnel diodes, and then we have advantages. We have discussed the advantages of tunnel diode, and then we have discussed what are the applications where these tunnel diodes are utilized effectively, particularly radio communication, and then logic circuits, high frequency circuits, satellite transmitters, and then we can utilize this in military applications. So several applications are there where tunnel diode is utilized for specific application. So that's all for today's session. The next topic will be varactor diode. Thank you.